A high-speed rail that can get on and off without stopping, can this be achieved? China's high-speed rail technology is world famous, but it is clear that China is unsatisfied with the current speed. How can the journey time be minimized? Some people pointed out that if you go from the starting station to the terminal, there will be too many stops. If you cancel the stop, the speed of the high-speed rail will be faster. Indeed, frequent arrivals and stops at the platform are a big time consumption. For example, a high-speed train from Beijing to Shenzhen has to pass through 14 stations on the way, and the stopping time of each station varies from 5 to 10 minutes. This is adjusted based on the size of the site and the density of traffic. The total time for this train to stop is 125 minutes, which does not include the time when the train decelerates and accelerates before and after the station. If these stops, as well as the time wasted by slowing down and accelerating, can be eliminated, the speed of the high-speed train will be further accelerated. So designers who are pursuing the ultimate have a new idea, that is, non-stop high-speed rail. The high-speed rail does not stop at the station, but also allows passengers to get on and off the high-speed rail safely. How can this seemingly impossible concept be realized? What problems are there in the implementation? Okay, let's take a look. The high-speed rail does not stop at the station, but also allows passengers to get on and off the high-speed rail safely. How can this be done? Well, just let the relative speed of the passengers and the high-speed rail be zero, that is, when they are relative static, the passengers can get on and off safely. Based on the principle of relative stillness, Chinese designers proposed a top suspension transfer. This measure means that by setting up a new pod on the top of the high-speed rail, whenever the high-speed rail is about to arrive at the station, the passengers who want to get off will go to the pod in advance. Passengers waiting to board at the station will also enter the pod at the station. As the high-speed rail approaches, the pods at the station will gradually accelerate to the same speed as the train and are fixed on the top of the train, while the previous pods will gradually slow down to make way for the new pods and park themselves on the station track to get passengers off. However, there are obviously many problems in this plan. For example, how to ensure the speed of the pod is the same as that of the high-speed rail? Does it have to lay a track for the pod to run in advance, and it has to travel a distance before and after to complete the docking? At present, the speed of China's high-speed rail is 350 km per hour, which is almost 6 km per minute. The running speed of the pod should also be the same. How long does the track for the pod run need to be laid to meet this demand? If the pit stop speed is reduced, it will lose the meaning of non-stop getting on and off. However, if the entry speed is too high, it will extend the length of the station line of the train and increase the cost of renovating the station. This is the biggest difficulty in this plan. Even if the high-speed rail needs to accelerate to the speed of travel, it must be accelerated by 40 kilometers. Therefore, the expansion of the transfer track must be at least 40 kilometers. According to the calculation of the distance between Chinese national stations of about 120 kilometers, the total length of the transfer track construction will reach 1/3 of the total length of China's high-speed rail, which is an extremely huge process. According to the high-speed rail data released by the Ministry of Communications of China, the total length of China's high-speed rail is about 37,900 kilometers, and the cost of high-speed rail per kilometer is 150 million yuan. In addition to the huge investment, we also need to consider special circumstances. That is, what if there are too many passengers getting off at a stop, and a transfer warehouse cannot hold them at all? In other words, if an accident occurs during the transfer process, how can passengers be protected from harm in the high-speed operation environment? Is this necessary? So, do other countries have better solutions? In addition to China, other countries have put forward design proposals for this. British designer Paul Priesterman proposed a parallel docking transfer scheme, which is to prepare a city tram like a mobile station. When passengers need to transfer, it maintains the same speed as the high-speed rail and runs on the rails parallel to the high-speed rail. After they are relatively stationary, the doors of the tram and the high-speed rail will dock together, and passengers can transfer from the connecting door. After the transfer, the high-speed railway continues to move forward, and the tram circles back to the city. Istanbul, Turkey, also proposed a tail docking transfer scheme. The train carriage is designed to be modular, and the train does not need to stop when it arrives at the station. Passengers who need to get off enter the rear carriage in advance and wait for it to separate from the train and arrive at the platform. Passengers who need to get on the train will also take a special carriage, catch up with the train from behind, and then enter the train. So the question is, can these ideas of non-stop high-speed rail really be realized? Which option has the highest probability of being realized? For the Chinese design scheme, the pods are located at the top, and the train and the platform need to be transformed. At the same time, the height of the train and the turnaround carriage must be considered, whether it can pass through the tunnel, and whether the tunnel needs to be transformed. The pod accelerates along with the moving carriage. Under the huge acceleration, can the people in the pod be able to withstand it? For the British scheme, it is mainly about the design of the mobile station and the handling of the connection method, and the line needs to be greatly transformed, and its safety-related issues may need to be considered more. Turkey's plan seems to have a high degree of implementation, and only needs to be transformed into the train compartment. However, it is very unfavorable for passengers who need to transfer. If you are unlucky, you need to go from the first carriage to the last. In short, in terms of the size of the system transformation, perhaps Turkey's plan is easier to implement. But if the overall effect is concerned, China's plan will be more dominant. In general, the original intention of the construction of non-stop high-speed rail is to reduce the energy consumption of high-speed rail and further accelerate the speed of high-speed rail, but it ignores the feasibility of actual operation and the safety of passengers. Therefore, it is difficult to implement non-stop high-speed rail in the future, and it can only be used as one of the alternative development directions of high-speed rail in the future. What do you have to say about their options for the non-stop high-speed rail? Other than that, what advice do you have? Please put your comments below, and share your insightful ideas with other people. Well, thanks for listening, everyone. If you have any suggestions, just leave them in the comments section. We'll come back as soon as possible and check them, and then we'll give feedback. See you next time.